In this video, I will show you how to do a mirror frogs data analysis. So, data analysis, you are doing the science research. First, you have to formulate your question. Your question about something is unknown. Yeah, and your question is meaningful to the science, is important to society. Yeah, everybody have many questions. So when your question is deserve to discuss and to find answer, your question is not known. Your question is not sure. Yeah, your question may be on debate. Yeah, your question is not does not have clear answer. Yeah, your question have hypothesis. That's your guess. Then use your data and some approach to testify, to verify your hypothesis is right or wrong. Yeah. So this scientific game is quite simple, but you have to follow about this. So this is my paper. This is 11 years ago. Yeah. So I have done in that at that moment. So Flash Data Net had not much data size like today. Yeah. So yeah, you see, second author is Daniel Ricciuto, was a PhD student of my postdoc advisor, Professor Ken Davis. Yeah. So then he worked at DOE. Then he had data. I asked Daniel, Dan, could you give me your AE numbers? Let me to play. So then he gave me some numbers. Then I started to ask another PI's tower flux principal investigators, yeah, to ask data, to gain data. But now you have the data, you have so abundant Amirfrost data. They have hourly, daily, monthly, yeah, seasonally, and yearly. Yeah. So you have abundant data already there. Yeah. Okay. Let's start the story. What a question? Question is important. Does climate control? AE. That's my research question. Climate control AE on hourly, on daily, on weekly, on monthly? Clearly, strong relationship between AE and temperature, AE and precipitation, AE and net radiation. Yeah. However, on annual time scale, yeah, it's not sure. On annual time scale, there's a different answer. So why? But I believe this annual AE or decade AE is controlled by climate factors. You can see these different biomes. Yeah. So from biome, yeah, for each biome, they have similar plants, similar animals, similar temperature, similar precipitation. But from biome to biome, they have distinguished the difference for the climate factors. From biome to the biome, they have different organic carbon storage. Tropical rainforest, tundra, grassland, they are different. They have different GPP, NPP, yeah, and the total ecosystem respiration, right? Yeah. Then you see this desert, no organic carbon. Why? Because too dry, no water, no photosynthesis. Yeah. In the tropical rainforest, it's the most productive. Yeah. It has a huge diversity. Why? Because the energy is abundant, hot, warm, and water is abundant. Yeah. So that's productive. This is climate control. Yeah, this from a simple this provides simple evidence. So here there is a group, Dr. Max Richard Stein. Yeah, this is from Germany, Max Planck Institute. He Max was the leader of his huge team. Is about 20 PhD students and postdocs and scientists. They are the full-time researchers, investigators, scientists. They do not have a teaching job. All the time focus on to study relationship between NEE and the climate factors. Yeah. However, this Mark's team has published a few papers before this 2009. Then his team had clarified, NEE on an annual time scale is insensitive to climate factors. For the monthly, for the seasonally, for the daily, is okay. Yeah, we are great. But on annually, on the 10 years, decadally, he clarified, no, NEE is not controlled by climate change. Yeah, that's his hypothesis or his conclusion. Yeah. However, I was a farmer. I believe on an annual and a longer time scale, he is still controlled by climate factors. Yeah. So this is my guess. This is my hypothesis. You see, you have a research question. So what's your guess for the answer to the question? That is a hypothesis. Your answer, that your guess, your hypothesis, you have to use some data approach to verify it, objectively is right or wrong. So that's my hypothesis. Climate factors are the dominating factor in a annual variability. So I want to test my hypothesis. Use the data. I used 125 edifloss tower set in the world. A lot from United States, Canada, and European, and Japan. A few from China and Australia. Totally, I got 125 the data from 125 tower sites. Some sites maybe have longer measurement, like a Haverford site. Maybe 50 years. Maybe some sites only have 3 years. Totally sum them up there are 559 years. We call it set years. Set years together. Yeah. What I'm doing now, I'm talking about what approach I'm going to use to verify my hypothesis. Yeah. So what I'm going to do, I'm going to do to make average. If Harvard have 15 years data, yeah, for there's the 15 annual AEE, there's the 15 annual temperature, 15 annual precipitation, 15 annual net radiation. I make average. Yeah, 15 years AE sum up divided by 15. That's one AE. That's called the set year average. 15 years have 15 annual T. Sum them up divided by 15. You got 1 T. Yeah, similar. You can get 1 precipitation, 1 net radiation. This is called set year average. Even 3 years, you just 3 T make average. Yeah, also got 1 T, 1 P, 1 net radiation. So, I have 125 size. I have 125 A, T, 125 P, 125 net radiation, 125 data points. Yeah, I want to use this data point to verify my hypothesis. Yeah, you do some data processing. Yeah, so then put them data in a chart, right? Excel. This X, yeah, X axis is annual mean temperature. Y is the annual mean AAE. How many data points? 125. Yeah. So that's 125 PI scientists. I got 1 point from each of them. Put them together in this chart. I'm seeking for a common pattern. I'm seeking for there's some relationship between this AE and temperature. However, you can see no correlation almost. Yeah. No common pattern. That's why Marx has clarified this AE is not insensitive to the temperature, to the climate factors. How about the dryness? X is dryness, Y is AE. The correlation almost zero. No relationship. So you see, this is the why Marx has clarified AE is insensitive to climate factors. Yeah, this is only one try, but I still believe this AE has a good relationship with temperature, with dryness. This is only one way. There's many other ways you have to try to verify your hypothesis. You cannot stop at one way. Yeah. So you see the Edison invented bubble has been filled 999. Only one was successful. You have to try many ways. What did I try? How did I do? I just grouping them. 125 data points. They have different vegetation. They have different location. They have different properties. They have different relationship. I group them. How I did the group? Yeah, I just used two Excel file. I put one group here, one group here. Then I move one side into this group. Then see if it increases the correlation. Oh, that's good. Just stay. If I see this data point does not increase the correlation, I think no. Have to move this group to another dryness control group. Yeah, eventually, then I found two outstanding group. One's temperature control, another is dryness control. However, do you think the approach I used is properly? Is appropriately? No, that is subjectively. That is by my hands, by my intention. So then I invited, a statistics professor from Department of Statistics at Penn State University, Dr. Lee, Renzo Lee. Then he knew how to professional grouping this data set, use a professional program as a statistic standard approach. Then he used a computer program that's grouping these 125 data sets into three groups. One is temperature control group, one is dryness control group, another is controlled by both temperature and the precipitation. We call it B group. This is a temperature control group. Then you can see on the x-axis is the temperature, y is AEE. They have a robust relationship, right? R squared is equal 0.84. In this group, how many data points? How many tower size? 46. Where they are? 76 of this set located in high latitudes. Doesn't make sense. Temperature is higher, growth season is longer. Have more time to do photosynthesis, more productive. So that the AE will be more negative. More CO2 from atmosphere move to biosphere and become into organic matter, right? That makes sense. That's meaningful. In high latitude, temperature is the key. If that's warmer, I can do more photosynthesis. So, for the dryness control group, you see this X is dryness, Y is AEE. That's dryness bigger, larger, more dry. More dry. Photosynthesis in the water, more dry. Less photosynthesis, less CO2 move to the biosphere. It is less negative. Doesn't make sense. That's meaningful. Right? This R squared is very high, 0.81. How many data points? 48. Where they are? They are in the low latitudes. Low latitudes. It's hot. temperature doesn't matter. Does not matter. Yeah, because hot enough. You give me water, I can do more photosynthesis. Water is a control factor. Makes sense. Meaningful. So B group, not a depend on a temperature. Yeah, it's around mid latitude. Yeah, 45 degree. Yeah, not only depend on temperature, also depend on uh, dryness. Yeah, because it is in the between high latitude and low latitude. So that's depend on both temperature and dryness. So we call it B group. Yeah. So here, this data analysis is verified and is controlled by the climate factor. However, that depends on where they are. High latitude, low latitude, and mid latitude, right? Its control factor are different. NE is highly limited by temperature and high latitude, by water availability at low latitude, by both temperature and dryness around mid latitude. That's the conclusion. Yeah, this is a conclusion. This is from the data, from analysis, right? Yeah, to be answered my research question, to be testified my hypothesis. Yeah. So we have this conclusion. This conclusion would be useful think something in the future, in the next 100 years. In next 100 years, where are the most warming? Global warming, no problem. Global warming in next 100 years. However, not everywhere warming in the same speed. Yeah, some part of Earth is warming faster. Some part of Earth is not warming so fast. Where is the warming faster? High latitudes. Yeah, high latitude warming faster. How about the CO2 flux? Based on our results, it's warming in the high latitude. Temperature control, yeah, it's warming that would be more negative NE, would be more carbon from the atmosphere moving in the biosphere. Good, yeah. So, how about in the next 100 years? How about the water, where precipitation will be less? Subtropic, yeah, subtropic. This precipitation reduction would cause what a problem based on our conclusion. Yeah. If dry, less negative of AE, less CO2 from atmosphere transfer to the biosphere. Yeah. So it will remain more CO2 in the atmosphere. That would be a problem. There will be issues that will be accelerate this global warming. Yeah. So that's the conclusion. So here, our conclusion is that, yeah, our results show that temperature is the most important control on carbon flow in high latitude. While water is the most important control for the carbon movement in the low latitude. As a result of global warming effects during the 21st century, we predict that the carbon flow from the atmosphere into ecosystems will be strengthened in high latitude while being weakened in low latitudes.